Okay, so we have now covered the 4 types of intermolecular attractions that are discussed in this chapter: dispersion forces, dipole-dipole, hydrogen bonding, and ion dipole forces. So how do we use that information to determine which force is present in an atom or molecule? So this flowchart, following this flowchart, will help you determine the type of intermolecular attraction or attractions that are present in a molecule. So one of the first things that you need to determine when given a molecule is to determine if it is polar or not. Meaning, is there a separation of charge in that molecule? And you can determine polarity by drawing the Lewis dot structure, determining if it's polar from the Vesper notation, or if you have a molecule that's linear, like N2 or HCl, you can determine its polarity by using the electronegativity values in the electronegativity table in the previous chapter. But the first thing you need to do is determine if the molecule is polar. If it's not polar, then you should ask yourself, is it ionic? Things that are ionic, that means metal and a non-metal. If it's not ionic and not polar, then automatically the force present is just dispersion forces. And what I tell my students is that if you're presented with a molecule and you have no idea what intermolecular attraction is present, always say dispersion forces because those are present in all molecules. Okay? But if something is non-polar and not ionic, just dispersion forces. If it's ionic, then it would just be ionic forces. If you have a mixture of polar and ionic compounds, like NaCl in water from the previous video, that force would be ion dipole force. So, once you determine if it's polar, if it is polar, your molecule, then you need to ask yourself, if it's polar, is there a hydrogen that's present in the molecule, and is that hydrogen directly bonded to a nitrogen, oxygen, or fluorine? If it is, then you automatically have hydrogen bonding. If it's not, then you just have a dipole-dipole force. Okay? So we're going to use this flow chart to do 2 examples in this video, and we'll do some more examples in 2 more videos. But let's use this chart in our knowledge to identify the intermolecular forces for these molecules, and let's start with N2. So with nitrogen, N2, we were to draw the Lewis dot structure for that. We did that in a previous video, so for Lewis dot structure. So here's the Lewis dot structure for nitrogen. And hopefully you can see that this molecule is going to be non-polar, or there's no separation of charge because both atoms are the same. They have the same electronegativity value. So if you were to take the delta En, that'd be 0. So is this molecule polar? It is not polar, so no. Is the molecule ionic? Is there a metal and a non-metal? Nope, it's just 2 nitrogens, just 2 nonmetals. So the force that would be the force that is present in N2 would just be dispersion forces. Next one, NH3. Is the molecule polar? You've got to do the Lewis dot structure for that. We did that in a previous video. Here's the Lewis dot structure for NH3. Is it polar? Well, that lone pair of electrons on nitrogen tells me that, oh, it is indeed polar. My central atom is attached to all the same atom, but that lone pair of electrons on the central atom tells me it is indeed polar, so this is a polar molecule. So I'm over here, so it is polar. Do I have a hydrogen that's directly bonded to nitrogen, oxygen, or fluorine? Yep, I do. I have a hydrogen directly bonded to a nitrogen. So I have not only hydrogen bonding present, but I also have dispersion forces, because dispersion forces, as we said, are present in all molecules. So those are two examples of how to use this flow chart and your knowledge of electronegativity and Lewis dot structures to determine types of intermolecular forces that are present. In the next video, we'll do the rest of these molecules as well as some larger ones as well.